Monday, guys. I know it's your first day of spring break, and like I said, this is an opportunity for you to help boost your grades up. This is going to be the first of 5 videos, okay? Now, these come back to the lessons in your book. If you took your book home like you were told to do, then you have your book. If you didn't have your book, I came around and gave you a packet that contained all the lessons, including the homework assignments. So you should have everything you need in order to write down everything that's on this board. In order for you to receive full credit on both the classwork and homework-based assignments, you need to make sure everything is written in your books. If there's not enough room, write it on a separate sheet of paper and make sure to stick it with that specific lesson. Do not come into the class next week on Monday and say, Mr. Hale, I didn't know. All right? You have plenty of friends that do know. Do not come into my classroom and expect me to give you credit for putting 2 words on the piece of paper. That's not the way this works. You have to attempt this if you want full credit. This is your last chance to improve your grades. Come Monday, if I do not have this stuff, I'm going to leave your grades as they are in the grade book. You will not get a second chance. I'm sorry if this ends up failing some of you for the year. That was never my intention, and I hope to God that you have learned your lesson from this quarter. All right, so as you can see on the board, it says Module 4, Lesson 13, Changing Scales. That's the first lesson we're going to work with. Module 4, Lesson 13. Don't ask me page number. If you got the worksheets, this is the very first lesson that's listed. If you didn't get the worksheet packets, then you're going to have to dig. Remember, the Module 4 is in the second half of the book. Lesson 13 is getting towards the end of the book. So that's where you should be finding this. Now, changing scales. Now, we talked about scales when we talked about the constant of proportionality. So we're actually taking that and we are going ahead and expanding upon that. We're not going to be just doing, some fraction work and that's it. We're looking at percentages, we're looking at enlargements, reductions, and so on, so on. The stuff that we learned when we talked about scale factor, I believe, back in Module 2. So this is not new information. This is actually review information, hence why we are doing this over spring break instead of in class. The quicker we get to Module 5, the quicker we can start getting to the meat of what's on your 10-ready test. All right, so this is the very first opening exercise. This is the classwork assignment. Now, they tell you what the definition of scale factor is and how you find scale factor. The scale factor is when you take the length of the scale drawing and divide it by the length in the original drawing, but it's got to be the corresponding length. If you take one specific side from the scale drawing, you've got to take that exact same side from the original drawing. You can't mix and match. And once you start mixing and matching, you start getting different answers, and that throws off your solutions. Now, it says describe using percentages the difference between a reduction and an enlargement. Well, a reduction and enlargement we should remember quite well, but we all know that there's always a hiccup. All right, so let's talk about our reductions and our enlargements so we can remember. Okay, scroll down here. All right, so the difference between a reduction and an enlargement. Well, let's write 2 columns here, reduction. And enlargement. So we got our 2 columns. Now, let's go back and let's think about the differences between a reduction and enlargement. Well, a reduction is when we shrink an object. We make it smaller than the original picture. Where with an enlargement, we make it larger than the original picture. Okay? So reduction is when we shrink it, enlargement is when we make it bigger. Now, if we think about this in the terms of percentages, okay, 100% will represent the original image. So a reduction has got to be an image that's going to be less than 100%. Whereas an enlargement is going to be an image that is going to be greater than 100%. Okay? So that's in terms of percentages what the difference between a reduction and an enlargement is. A reduction is when we found an image that is less than 100% of the original, whereas an enlargement is going to be greater than 100% of the original. All right, so let's get into this, okay? And I'm telling you right now, if I was you, I'd make sure I wrote this on every page I'm working on, okay? So it's the length of the scale drawing versus divided by the corresponding length of the original drawing, okay? So what I would do, like I said, first thing I would do is I'd write down scale over original, since that's what we're going to be working with. We're working with scale factors, so we need to remember the scale over the original. Now, this is the next assignment you've got. It says using the two drawings below to complete the chart. We're going to calculate the first row, drawing 1 to drawing 2 only. Okay, so that's what we're going to do. We're going to calculate drawing 1 to drawing 2. Okay, so here's your column right here. It says quotient of corresponding horizontal distance, quotient of corresponding vertical distance, scale factor as a percent, reduction or enlargement. Okay, so drawing 1 to drawing 2. Now, I'm going to skip the first 3 columns, and I'm going to go straight to reduction or enlargement. Why would I go to reduction or enlargement? Well, it's easy, because it's obvious. It shouldn't take me that much of a think process in order to figure out that drawing 2 is bigger than drawing 1, is it not? So if drawing 2 is larger than drawing 1, that has to be an enlargement. Drawing 1 to drawing 2 is an enlargement. Okay, so if drawing 1 to drawing 2 is an enlargement, is the scale factor going to be greater than or less than 100%? Well, that's going to be right. It's going to be greater than 100%. So we can go ahead and start writing that in real quick. We're going to be looking for an answer that's greater than 100%. So in order for me to get a quotient that is going to give me a fraction, a percent that's greater than 100, all right, the scale length has got to be greater than the original length. And I know you're sitting here saying, Mr. Hale, what do you talk about? You're starting to lose me. Okay. Go back and think about this. So if I've got an apple in one hand, and then in the other hand I have a 10-pound apple. So I got a 1-pound apple in my left hand, I got a 10-pound apple in my right hand. Is my 10-pound apple not bigger than my 1-pound apple? Yes, it is. Okay, so my 10-pound apple is an enlargement. It's obvious because the 10-pound apple is bigger than the 1-pound apple. Well, in this picture here, drawing 1 is smaller than drawing 2. So drawing 2 is a larger picture. So drawing 2 is the enlargement. Now, remember what we talked about when we decided what reduction versus enlargement was. Okay, an enlargement is a drawing that is going to be greater than 100%. So we're looking at a value greater than 100% when we're talking about our percentages. So in this situation here, in order for me to get a number that's greater than 100% as a fraction, the scale length has got to be bigger than the original length. So we have to identify which one's the scale and which one's the original. Well, if the scale is going to be larger than the original, this tells me that drawing 2 for our purposes right now is the scale, and drawing 1 has to be the original. Okay, so I know you're sitting here like, but Mr. Hale, why isn't drawing 1 the original and drawing 2 is the scale? Well, because we're scaling up. We're making it bigger than the original picture. Okay, so let's look at the quotient of the corresponding horizontal distances. Now remember, horizontal goes left to right. So this is left to right. So that's the original horizontal distance, and here's the scale horizontal distance. So my quotient is 3.92 over 2.45. All right, now the quotient of the the quotient of the corresponding vertical distances. Vertical goes up and down. So we're looking at the ones that go up and down this time. So I'm looking at 2.4 over 1.5. Now you're saying, Mr. Hale, how am I supposed to find out the percentages? Well, this is a simple division problem. Now, if we've done everything right, both these quotients should give me the exact same answer. So that means I have to do a little bit of division here real quick. So I got a calculator in my hand. I got 3.92 divided by 2.45, and I get 1.6. Now I got 2.4 divided by 1.5. Again, that's 1.6. So if these values are identical, then I've done everything right. I've got the same answer. Now how do I convert a decimal to a percent? Right. I multiply it by 100. So 1.6 times 100 gives me 160%. Okay, so there you go. Our scale factor as a percent is 160%. The scale drawing is 160% larger than the original drawing. Okay, so let's come down here. Drawing 2 to drawing 1. So this time we're doing it backwards. Drawing 2 to drawing 1. So this time the numbers are flipping. Remember, this was drawing 2 versus 1. This time now we're looking at 1 versus 2. How do we know that? Well, it's because if we go back and take a look at our pictures, drawing 2 now has become the original, and drawing 1 has become the scale. So that means we're now looking at a reduction in size. So if we know that we're looking at a reduction, that means we're going to be looking at a percent that's got to be less than 100. In order for us to get a value that's less than 100, that means the numerator has to be smaller than the denominator. So we're just going to flip the values. 2.45 over 3.92. 1.5 over 2.4. Now, if I've done everything right, I should get the exact same decimal value for both. 2.45 divided by 3.92, I get 0.625 for the first one. 1.5 divided by 2.4 gives me 0.625. Now, what's 0.625 as a percent? Right, we just multiply it by 100, we get 62.5%. Is 62.5% less than 100? It is. So we obviously now proven that it is going to be a reduction. Okay? Now, compare drawing 2 to drawing 1. Using the completed work of the first row, make a conjecture about what the second row of the chart will be. Well, we've already done that. Okay, we've already computed the second row. We've already taken everything. So we obviously already proven that if we flip the values, we change whether or not an image is going to be an enlargement or a reduction of the original picture. All right, let's move on. All right, so the scale factor from drawing 1 to drawing 2 is 60%. Find the scale factor from drawing 2 to drawing 1. Okay, so from drawing 1 to drawing 2, the scale factor was 60%. Okay, so now I'm going to pose this question to you. Is this going to be a reduction or enlargement? Right, it's a reduction. Since the scale factor is less than 100%, drawing 1 to drawing 2, this is a reduction. So from this direction to this direction, we are looking at a reduction. So going from 2 to 1 would be a what? Right, an enlargement. Okay, so it says find the scale factor from drawing 2 to drawing 1. Okay, so let's go back and let's look at this. To find the scale factor of any image, we take the scale length and divide it over the original length, right? Well, what's 60% as a decimal? Okay, well, let's convert it real quick. 60%, so that means we're going to divide this by 100, and we get 0.6. Well, 0.6 as a fraction is what? 6/10. So there you go. You got a fraction now. Now, is a fraction not just a quotient? Correct, it is. So my fraction is actually my scale factor. It is 6/10. So my scale factor from my original drawing, from drawing 1 to drawing 2, was 6/10. Now go back and look at what we did in the first chart. When we were asked to find from drawing 2 to drawing 1, we flipped the values, right? Because basically the idea is that this 2 represents a 6, and this 1 would represent a 10. So to go from here to here, we took 6 and divided it by 10. So to go from 2 to 1, the new scale factor would be then drawing 1 over drawing 2, which would be 10/6, which would be 140%. And you're like, Mr. How did you figure that one out? Well, actually, it's not 140%. If you actually did the math, it's wrong. I wanted to see whether or not you'd actually question me on this one. All right, so 10 divided by 6, okay? Well, we can't do 10 divided by 6, but I can borrow real quick. Okay, 6 can go into 10 one time, leaving a fraction of 4, 6. So this is 1 4/6. Well, 1 4/6 reduces to 1 2/3, which gives me a 166% enlargement. So to go from 2 to 1 is 166%. It grew 166% of the original shape. That's all that is. That's all you're doing on scale factor. It comes back down to the scale drawing versus the original drawing. and understand whether or not it's going to be an enlargement or a reduction. Okay, a regular octagon is an 8-sided polygon with side lengths that are all equal. All 3 octagons are scale drawings of each other. Use the chart and the side lengths to compute each scale factor as a percent. How can we check our answers? Well, it comes down to common sense. Now, if I was you before I continued, I would go ahead and write down these links because it's going to get a little interesting because we're going to end up having to go down and we're not going to see all this. Okay, so now we can do a little bit of work. All right, now let's pull this up here real quick and let's come down. All right, so with the scale factor from drawing 1 to drawing 2. Okay, so drawing 1 had a measurement of 10. Drawing 2 has a measurement of 12. So is drawing 2 larger than drawing 1 or smaller than drawing 1? Okay, right. It's going to be larger. So the scale factor's got to be greater than 100%. So all we're doing is we're just generating our scale factors. Okay, so what's the original? The original is 10. It's drawing 1. So our original length is going to be 10. Our scale length is going to be 12. So that's 1 2/10 or 1 1/5, or it's going to be 120%. Okay? Or if you wanted to go a little bit further here, you can reduce this to 6/5, and then you can find your answer faster. Okay? What about drawing 1 to drawing 3? All right, drawing 3 is a reduction, so that means we're looking at a shrinkage. Okay? We're looking at a percent that's going to be less than 100. So drawing 1 is still the original drawing. So drawing 1's scale factor has still got to be 10, or this drawing 1's original length has got to be 10. The new length has got to be 8. So we're looking at 8/10. 8/10 reduces to 4/5, which equals 80%. All right, what about drawing 2 to drawing 1? Well, drawing 2 was 12. Drawing 1 is now 10. Drawing 2 is going to be our original image. Drawing 1 is our scale length. So am I looking at a reduction or enlargement? All right, I'm looking at a reduction. So drawing 2 is our original, which is 12. Drawing 1 is our scale, which is now 10. Reduce that, that's 5/6. Now, 5/6 as a percent would be, we're going to round off here and say it's 83%. Okay? What about drawing 2 to drawing 3? Well, drawing 2 is the original. Drawing 3 is the scale. So am I looking at a reduction or enlargement? I'm looking at a reduction. Okay? So drawing 3 is the 8. Drawing 2 is the 12. Now I got to reduce this. So if I divide these both by 2, I get 4/6. Divide them again, I get 2/3, which gives me a wonderful percentage of 66%. And I'm rounding here. Yes, I'm rounding off. It technically would be 66 2/3, just like the previous drawing would be 83 1/3. But we're rounding here. All right, drawing 3 to 1. So drawing 3 is 8. Drawing 1 is 10. Am I looking at a reduction or enlargement? I'm looking at an enlargement. So drawing 3 is the original, so that would be the 8. Drawing 1 is the scale, which is now going to be the 10. Divide these both by 2, I get 5/4, which gives me 1 1/4, which is going to give me 125%. So that's a 125% increase from drawing 3 to drawing 1. Last but not least, drawing 3 to drawing 2. Drawing 3 is the original, so the drawing 3's got to go on the bottom at 8. Scale now is drawing 2, which would be 12. 12 and 8 can both be divided by 4, which gives me 3/2, which is 1 1/2, which gives me 150%. All right? I'm not worried about the equations. If you can identify how to find the scale factor and scale drawing in any, or if you identify the scale factor in any scale drawing, then you're doing better. And that's the goal. I need to make sure that you can find the scale factor. Now, yes, I can guarantee you that you will have a quiz on this when you get back. All right? I need to make sure that you actually attempted to do this, because this is going to be on your 10 Ready test. I need you to know this. Okay, this isn't going to be one of those fly-by-your-pants kind of things. All right, your homework. So this is your first homework for the night. If you do this, then it's one less thing you got to do. This is an automatic 100 if you complete it, just like if you've completed taking your notes, that's 100 as well. So you're already up 200 points if you did it. So spring break homework number 1. We're going to complete all the problems in problem set for lesson 13. It's not many. I think it's only 4 or 5. So don't be, disgruntled about the fact you have to do homework. All right, this is an opportunity for you to improve your grade. That's the goal. This is the easiest assignment you've got out of the whole bunch, so remember that. Do not stack these on top of each other. Last but not least, because of the whole debacle on Thursday and me not being here last week, I did not get a chance to pass out your mid-module assessment quiz sheets. So I told you it was going to be for homework. Well, it's still going to be for homework, but you're going to have until Sunday to get it done. So your mid-module assessment is due by March 18th at 10 p.m. When you sign into the website at join.quizizz.com, I need your last name first, your first name last, just like it normally shows up on, your parents' driver's license. If you look at your parents' driver's license, it's the last name, then the first name. So that's the same thing. So, for example, let's go with Nija Jones. I expect you, Miss Jones, to put in Jones, comma, Nija. Mr. Miller, I expect you to put in Miller, comma, Christopher. Mr. Williams, I expect you to put in Williams, comma, LeKenrick. All right, Kamani, I expect you to put Williams, comma, Kamani. That's what I'm looking for. I don't want you to put in some goofy nickname, because the problem is if you put in a goofy nickname, I can't guarantee who it is, and you're not going to get a grade. I'm much more inclined to put in a 0 instead if I have to hunt you down. All right, so last but not least, like I said, the website, join.quizizz.com. So that's JOIN period QUIZIZZ period COM. So join.quizizz.com, and then your class code is 662045. I need to make sure that you all pass this information on to everybody, please. If you know somebody is not paying attention to these videos, then pass on at least the quiz information. They need to have them all done by Sunday. If I do not have a grade, then you start off the first semester with a 0. Or not the first semester. You start off the fourth quarter with a 0. All right. I will see you all bright and early Monday morning. Remember, this is the first video of 5, so do not goof off.